Okay, baik. Assalamualaikum semua. Welcome to ISP542 Fundamental of Artificial Intelligence guest lecture session in collaborative teaching. For today, we will be discussing about fuzzy logic and reasoning. So the purpose of this guest lecture session is because we want to do a sharing session about fuzzy logic and implementation in real world, including research. So as we have discussed in the class today and previously, reasoning in uncertain situation represent uh, learning in artificial intelligence, which perform higher level thinking. So usually it perform um, uh, it it complements expert system, especially in expert system, and it can also represent real world situation where not everything are literally black and white. So it not everything inside the real world would be can be represented by either true or false. So so today we are going to learn about this fuzzy logic. Can it represent a fundamental understanding of implementer on how to implement fuzzy logic in electronic system as well as in digital system, on how the machine would react to the environment, as well as it give reporting to the user based on input that it get. So I think Dr. Tajul is already here. So can you introduce yourself?
Assalamualaikum.
Yes,
Can
yes,
you,
Dr.
can you hear
Tajul.
my voice?
Ya, ya, ya. Boleh dengar Dr. Tajul.
Okay, all right. All right. Thank you very much, Cik Hafiz, for the introduction and for having me for this. I can call it as a session, a session for this particular topic, which is fuzzy logic and reasoning. Okay, before that, let me introduce myself. Okay, my name is Tajul Rosli Razak. I was a lecturer, okay, in UITM Perlis before, and then now I moved to UITM Shah. Okay, so I'm teaching CS230, okay, Bachelor of Computer Science in UITM Shah. Okay, so I am Cik Hafiz is we are in the same research group. We are working together with a few research, and my background is mainly on the fuzzy system. So I did my PhD also in the fuzzy system, but part of that I also involved with, the others area also under artificial intelligence, such as machine learning, deep learning, expert system, and now I also focus on the XAI available, explainable artificial, explainable AI, yeah, explainable artificial intelligence. So hopefully today I just want to share a bit about this particular topic, and hopefully also I can share some of the example that I did before, so that we can see, instead of learning this theory, how can we apply this theory, yeah, especially on the fuzzy, how can we apply into the real example, inshallah. So, Mr. Hafiz, can I share my slide?
Okay, okay, please do, please do.
Okay, thank you. Okay. Boleh nampak, Hafiz?
Okay, boleh nampak?
Right.
Interpretability, okay.
Okay, okay. Alright. Yang lain boleh nampak ke? Kita santai sikit lah. If you have any question, just feel free, okay? Put in the chat or just ask me straight away, okay? Hopefully just a session to share some a bit about uh, reasoning in uncertain situation, okay? All right. So I think I may start now. All right, Bismillahirrahmanirrahim. Okay, Assalamualaikum and very good night to all the students. Okay, thank you also for joining this session with me and also Mr. Hafiz for having me on this session. Okay, so for tonight, we're going to learn about reasoning in uncertain situation. Okay, just a bit theory, but later on we're going to see how we can apply. So actually, how AI, artificial intelligence, make decision with the incomplete and ambiguous information. So this is very important because in our real life, okay, in our real life, we have a lot of not uncertain information and uncertain decision. So here today, maybe a part of this, we're going to see how this AI can also tackle, okay, and make decision with the incomplete and ambiguous information. Okay, today we're going to see on the AI, expert system, certainty factor, and also fuzzy logics. So my name again, Tajul Razak. I'm a lecturer in the FSKM UiTM Shah. Okay, let's start. All right, so these are learning outcome. Learning outcomes, so we're going to see how to explain the uncertainty, okay, understand and the nature, source, type of uncertainty in a real world problem. And then there are two big things today for this lecture. We're going to see on the certainty factor and also the fuzzy logics. And at the end, how these both can help us to solve the reasoning problem. So for the certainty factor, we're going to compute and combine the certainty factor for the different rule structure and situation. And for the fuzzy, I don't know, maybe some of you have a basic or maybe not yet, but it's okay. Today, just a brief idea on how to understand fuzzy logics. Okay, to describe the fuzzy set, membership function, H, and fuzzy set operation. And thus, we're going to use the uncertainty reasoning technique to make the intelligence decision in the real world application, inshallah. So here is a quote here. AI is not only about finding the correct answer, but also about measuring the confidence in our decision. You know, when we give a decision, sometimes we are not sure with our decision. Okay, so that's why today we're going to measure the confidence in our decision. Thus, people might confident with our decision that we made. Okay, using the AI tool, for example. So why do we need this uncertain reasoning? As I said, the real world problems are really black and white. What do you mean by black and white? Okay, for example, here, if you're looking on the classical logic, okay, binary decision, we always have like a true or false. Okay, so these are too rigid for real life. Okay, for example, in our lives, not only black and white, they have a colors in our world, right? So that's why this one, okay, it's not true, false, it's not yes, no. So it might have something in between. Because in the real world, uncertainty is everywhere. For example, in the weather prediction, okay, even in the medical diagnosis, okay, and medical diagnosis sometimes, okay, I can say like this, okay, when you set a fever, okay, how much is it? How much your fever is? I mean, is it the very high fever or is it a low fever? You know, so they have uncertainty. For example, if we are talking on the fever, also in the traffic condition, okay, yes, we are having with a lot of traffic, especially in Shah Alam. I don't know, in the police, my experience was there no much traffic, but here in Shah Alam, there's a lot of traffic. But how can we describe how bad the traffic? So sometimes we cannot certain on this thing. Okay, how bad is it? Very bad? Is it not bad? You know, there is a uncertain. Also in the stock market, so in the human language. So here we can say the information is incomplete, okay, ambiguous and noisy in the real world. Right. So here is the challenge in the AI. So how can AI make a reliable decision with the uncertain information? Okay. For example, we want to do the decision, but we have not much information. Okay, in this uncertain information. So how could we challenge? Okay, how could the AI take a challenge? So AI challenge is a problem to overcome. Okay, when we have the incomplete information. Sometimes we have a conflicting evidence and then vague and imprecise term, and multiple possible. So AI must reason in the face of the uncertain. Okay, so that's why, sir, today we are going to look on the uncertain reasoning. Here is a solution. Okay, reasoning with the uncertain, we have two methods that we can use. The first one, we're going to look on the certainty factor. We're going to measure the confidence in the expert knowledge so that people might have a confidence. Okay, or we can also use the fuzzy logic. Okay, because fuzzy logic can handle the imprecision and the vagueness. Thus, make decisions that are intelligent and relevant. So that we can say, okay, now we are very confident with our decision. Okay, here is the topic area. Okay, we're going to see on the certainty factor and fuzzy logic system. So AI is not about the 100% sure. It's about being intelligently confident. Right? Okay, so now we're going to have a look in our real life example. Okay, where the uncertainty exists. Okay, here is the situation on the medical diagnosis. Okay, symptom may indicate several possible. Okay, let's say if you go to the UK, kesihatan, you make appointment with your doctor, you tell the doctor your symptom. Okay, and then from the symptom, maybe the doctor, based on their experience, they might give some diagnosis. Okay, oh, you might have not dengue fever, for example, right? So it would be a viral, okay, a dengue or typhoid. Sometimes the symptom might lead to a different disease. So they have an uncertainty, right? Because we need confidence, okay, not just yes or no, right? So that is the uncertainty, okay, the uncertain in the medical diagnosis. Sometimes in the weather forecast, okay. If you're looking, okay, for example, when I want to travel from my home to the Shah Alam, what I did is every morning I'm going to look on my phone to see the weather forecast. Okay, sometimes the weather forecast show you, oh, it's gonna be rain, okay, in 20 minutes. Okay, but sometimes it's not accurate. Sometimes, because they use the data. Yes, that is because you the data. Sometimes the way they describe, okay, for example, 70% chance of the rain today. So they put some, percentage to make us confident. Oh, 70% might be true. It might be raining, right? So when we look on this percentage, we might have some confidence, right? So we expect the decision in probability or confidence. So that's why sometimes when they have this number, it might trigger us, okay, we have this certain number, 70% chance of the rain today. So we also might confident this one, right? Okay, look at on the autonomous vehicle. Okay, if you're doing object detection or etc. Okay, using YOLO for example. So is that object is a pedestrian, a cyclist, or the signs? Okay, so yes, the AI will detect this, and if you're looking on the top of that, there's some numbers. Okay, for example here, okay, 0.25 is a cyclist. Okay, very low. Okay, might be true, might be not, right? And then even the sign, okay, the stop sign, the probably only 0.10, all right? So it's not very strong. But here, if you're looking here, the pedestrian, because they are looking, they want to detect the object, but this one, the AI very sure, so they give some 0.65. It might be this pedestrian that crossed the road. So AI must make safe decision with the uncertain inputs. Okay, and so in the financial investment market volatile and unpredictable, is very changed very quick and etc. So we have to evaluate the risk and possible outcome. This is some of the example, right? Might be more, okay, might be a different domain, etc. Okay, even in our daily life, we have a lot facing with a lot of uncertainty. This is just an example. So AI system must be able to reason, to learn and decide, okay, with the uncertainty, ambiguity, and incomplete information. Okay, right? So I will move to the next. Any question? Maybe not. Okay, we proceed. All right. So now we're going to see, because I will start with this lecture, maybe some of the theory to make us understand why it's a very important to capture this certain. Okay, on this slide, you're going to see how humans think. Okay, human naturally reason with uncertainty. Okay, not absolute certainty. Okay, again on this example of diagnosis disease based on the symptom. Here in the doctor here say, okay, based on your symptom, okay, I think this is probably dengue. Right. So that why not 100% sure? Okay, they're going to use the probably because they are not 100% sure, but symptom may have a because due to this, symptom may have a multiple cause. Okay, tests are not always perfect. Information may be incomplete. Maybe certain symptom not been told by this patient. Your human experience involve judgment. Okay, again, it's depend. Okay, if you go to the clinic A, clinic B, clinic C, you might get some of the different interpretation by the doctor. Okay, because of the human judgment. Right. So this is the key idea. We express our belief of degree of the confidence, not as a simple yes no. So that's why now we're going to talk about the to measure this uncertainty because we want to put some confidence, degree of confidence. Okay, not only simple yes or no. Will have some number. So this is how the uncertainty aware reasoning technique in the AI will develop. So technique we learn is about to measure the uncertainty factor, measure confidence in express system, and then fuzzy logics. Okay, handle the weights and imprecision. Right. Okay, here the first method here we're going to see on the uncertainty factor. So CF is a method to represent and reason with the uncertainty using the numerical confidence value. Okay, just now we are talking about the confidence. So we're going to measure this confidence value. So where did it come from? Okay, still 1960 is developed for the Mycins expert system at the Center of University. So the purpose is to help the doctor make a decision when the information is uncertain or incomplete. So application might be can be used on the medical diagnosis, care recommendation, and therapy selection. So normally when we involve with the decision that involve the people, it will be good, okay, to apply this one. So expecting in the degree of belief, not just yes, no. Okay, now we are going to inject this degree of belief, okay, by applying the certainty factor. Right. Certainty factor, or I can call CF value, is a range between -1, okay, -1 until +1. So if we have this area, okay, because if we are not sure or we definitely it's not true, for example, so it's definitely fall with range in this area, negative value. Positive value is might have go to definitely true when it's most reached to 1. Okay, so the positive value indicate belief, negative value indicate disbelief, and value near 0 indicate uncertain. Maybe you still not sure. Maybe you have some maybe. So maybe this one 0 still you uncertain. So the key concept here, instead of saying yes or no, so we may say, I believe this to a certain degree. For example, 0.8, almost certainly true. Okay, maybe 0.0 still unknown, still uncertain. But if negative 0.7, probably not true. So now, instead of kita guna, if we use the yes, no, now kita dah ada numbers, okay, untuk represent our decision. Okay, if you notice here, we doesn't want to use yes or no, but we do have some numerical to the confident value. Okay, so this will provide the structured way to handle the uncertainty in expert system and AI. So how it means? Okay, still we doesn't know what is a CF mean or scale. So a numerical scale to express the degree of belief or confidence. Okay, about the scale, okay, yes, it's between -1 to 1, +1, right? And then it shows how much we believe a hypothesis is true or false based on evidence. Okay, it helps the AI system reason with the incomplete, uncertain, or conflicting information. All right. If you can see here, okay, this is a quantum of belief. Okay, if you let's say your number will be here, so this is definitely false. Maybe in this area we can say, probably not true. But if you value got this one, still uncertain. But if you go to this one, you will increasing the belief, okay, until you got reached to 1, so we'll get the definitely true. Here is an example. Okay, if you say in -1, definitely false. I am absolutely sure this is not true. Okay, for example, -0.5, what does it mean? Okay, probably not true. I top in, okay, but not completely sure. So still not sure, but because he said, yeah, it's not probably not true. Probably not true. He dropped, but not completely sure. But here, if you got a zero, okay, still unknown, still uncertain, okay, I don't have enough information to decide because he's might still might not certain, right? So that's why the value is zero. Okay, might be false, might be true. But if you get positive 0.5, yes, this is probably true. I believe it's true, but not completely certain. But they have a degree of 0.5. But if you got 1.0, this is definitely true. Okay, I am absolutely sure this is true. Okay, you can see they have a different. Okay, this number will represent your belief and your decision. Therefore, a CF value allows AI system to mimic human reasoning by handling the uncertainty in structure and meaningful way. Okay, we want to understand more on this CF, okay, certainty factor. So I will call CF as a certainty factor. So CF is how expert system handle the uncertain and incomplete information to reach the conclusion. So now we're going to see how it can be measured. Okay, first we are looking on the evidence. For example, in this case of the doctor diagnosis, let's say we observe and gather the facts from the environment. Okay, here, for example, okay, the doctor say, okay, the symptom here is the patient has a fever. Okay, now go to the next step is expert rule. So we're going to apply the expert knowledge in the form of if else. Okay, when we want to do rule, it's called if else rule. So okay, they put this one. Okay, now if fever, then flu, meaning that the symptom is the antecedents, this is the input here called fever, and then the consequent is flu. They put in the structure of rule, and then they try to see the confidence. So we assign a degree of belief CF value to the rules and the evidence. So how confident are we? Okay, CF range negative to positive one, meaning that between definitely false and definitely true. And then they combine number 4, the last step is to make a decision. We combine the confidence with the rule to reach a conclusion. Thus, what a conclusion to be met? Example, the patient may have flu. So now they have like a may have flu. So maybe they're quite certain this is based on their symptom. Okay. This symptom, the patient may have flu. What is it? The flu does mean fever. So here is a basic formula to calculate the CF. All right. Here is a CF, okay, in bracket they have a H and E. So what is CFE? Is a evidence, okay. E stands for the evidence here, okay. And then CF rule is CF assigned to the rule, okay. For example, we got the rule, we're going to put the numbers of the CF. So if we got 2 numbers here in the evidence and also in the rule, so we might have the multiply between the CFE and CF rule. So CF combine the belief in the evidence and the rule to support the conclusion. Okay, let's say kita dapat jawapan and also we want to see what is the numbers. Okay, this number will appear into the decision, so this will support our belief. Right, this is the step involved, but how to measure? Here is an example, guys. Okay, let's say we have a simple example case, okay, to a weather forecast or weather case. Let's see how CF works with one rule. Okay, this example just one rule. Okay, let's say the evidence say, oh, sky is clear. Okay, so see, we have a CFE evidence. The sky if clear is a 0.5. Right, and then the expert make an expert rule. Okay, if sky is clear, then sunny. So in the CF rule, they have numbers like 0.8. And then the last result is just to multiply lah, because the calculation is CFE multiply with CF rule. So in this case, 0.5 multiply 0.8, and then the final CF we're gonna get 0.4. And then what does it mean? How to interpret? So the interpretation is maybe sunny, because maybe this is this area. Okay, it's not definitely true, but still maybe sunny. Right. So 0.5 is closer to the unknown than definitely true. So that's why we say maybe sunny. You can see. So CF help us to express how confident we are, not just yes or no. Okay, now you can see the difference now. Okay, instead of we want to talk about, okay, what is the weather today, right? So now, based on this, evidence, rules, and the result calculate, we got the final CF. Okay, by using the final safety factor, okay, it might help us to interpret, okay, to give the decision on this weather case. So therefore, here in this case, they said that, oh, this maybe sunny, right? Because of this value. So now people might have this confidence. Okay, they not argue because we have this value now, right? So CF help us to express how confident we are, not just yes, no. All right, let's do it together. Okay, again, the same apply. All right, let's say use the CF formula to find the final confidence. Okay, again, first we have this rule, because either rule first or evidence first might be okay. All right, let's say if favor, then flow. Okay, the confidence now is 0.8. Okay, the CF for this rule is 0.8. And then for the evidence, okay, for the evidence that fever, okay, how confident are we that the patient has a fever? Let's say we put 0.8. Okay, and then what is the final CF for this flu? Of course, we just multiply, right? As we mentioned here before, right? CFE multiplied by CF rule, and then we got this value 0.5, right? So what does it mean by 0.5? Okay, so now we got like a 56% confident that the patient has flu, right? So this number have help us to the degree of belief, right? So just 56%. It's not 100 yet. So that's why we might say that, oh, this patient might have a flu, maybe has a flu, because 55% only the confident, right? That is the way how to measure, right? Is it okay? I think it's okay. It's very clear, because the topic now is very just a simple example, right? So this tells us how strongly the evidence support their conclusion. All right. So that is a one rule. How about if we have many rules? Okay. In our case, we might have a very much rule. Okay. So here is we're gonna see called the multi-antecedent, because in one rule, if you notice, in rule if else, we might have a if, if, then. Right? So if if, so there's an antecedent A, antecedent B, antecedent, so that is the evidence. Right? So let's say here, all the condition must be at least partially true. Okay, because first we're going to see the rule. If you notice, if evidence one is A N, kan sometimes dalam rule tu kita ada operation kan, ada N. So now we're going to see on the N, antecedent N, multiply the antecedent by N. So let's say here, okay, first evidence is sky is clear, CF 0.9, okay, and then evidence number 2, temperature is high, 0.8, and then the last is forecast is humid. Okay, the humid is 0.87. Okay, so this is probably to forecast whether gonna rain or not for the tomorrow. Okay, now because of we use n, okay, because we use the n, and then we might take a mean. Okay, because because using this mean, we're gonna take the minimum of the CS. Right. For example, here. Okay, rule is the sky is clear and the temperature is high and the forecast is humid. Okay, remember we're gonna calculate here, but here is have a multi-antecedent. Okay, multi-antecedent, and then they're using n. Okay, dalam rule tu kita guna n. So kalau kita ada n, in this case kita ada 1, 2, 3. Okay, we have 3 antecedent here, and then antecedent represent the evidence 1, evidence 2, evidence 3. Okay, remember just this rule. Okay, if you're using n, then we're gonna take the minimum. For in this case, the result of CF antecedent we call 0.9, and then because of the minimum, we're gonna got the for this all this combination rule, we're gonna got the final CF is minimum value 0.5. Okay, that is the rule. Okay, when we apply antecedent. Okay, things the weakest of condition limits the strength of the completion. The key takeaway here, okay, for the N rule, we use the minimum CF because the weakest evidence limit the confidence of the conclusion. Kalau awak ingat, if you remember, kalau kita pakai and, everything all must have a true. Must have true, and then we go under fire. So that's why, to be safe, they will take the minimum value. All right. So that's based on 0.7, yes, they also then rain gonna tomorrow. Okay. Then rain tomorrow. Maksudnya tomorrow hujan. Okay. We using the numbers of 70%. Okay, 0.7. So the overall confidence cannot be stronger than the weakest condition in the N. That's why kita ambil yang minimum. Yeah. So why minimum for N? Okay, here is another example to explain why we apply the minimum. Okay, think of the N in the water system. Okay, let's say here in the condition 1, we have the CF 0.9 using the large pipe. Okay, condition number 2, okay, using the medium pipe, 0.8, right? And then the last condition, for example, we have a very small, okay, small pipe, now is a 0.8. So what is the final output? Because we want to use N. So to be safe here, okay, to be safe, that's why we take the small value here, okay. We're going to see the final CF, the small will represent everything, right? So that's why we take the small one. So the system conclusion can be as strong as is the weakest part evident. That's why N use a mean, right? The idea is that all pipe must allow the flow, water, and then the small pipe limit the flow, okay, because they're small. So in the N rule, all the condition must be satisfied. Remember, kalau guna N, semua kena true. Condition tu semua kena true. So the weakest minimum condition limit the overall confidence, meaning that kita dah guna yang minimum tu dah boleh represent everything lah, okay, by using the N. Okay, key takeaway here, N use a mean because the weakest evidence limit the strength of the conclusion. Right, that's the reason using N for minimum. Okay, vice versa. Okay, the opposite of that. Okay, sometimes we might see the rule that using or. Okay, if A is B or if C is A or and then right. In this case, using or, we're gonna take the maximum. When the rule has a multiple condition connected by or, we use the maximal CF, okay, among all the evidence. Okay, for example, let's say the sky evidence 1 have a 0.3, evidence 3 have a 0.6, so evidence 2 have a 0.6, evidence 3 have 0.8. Okay, for example, now destination here, okay, if we go to this one, 0.3, and then 0.6, and then 0.8. So what is the last result, the last CF? All right, so for the result for this call center, we're going to take the max. Let's say we take the max of CS because one strong evidence is enough to support the conclusion. Tadi kita ambil yang minimum because this minimum can cover all decision. But by using or, we're going to take the maximum. Okay, so the max CF because one strong evidence is enough to support. Because kan or to campur, right? Okay, so think is one is a good reason enough, right? Key takeaway here, okay, for all rule, we use the maximum CF because the stronger evidence can support the conclusion. So real life analogy, to reach the destination, in this case, to reach the destination, you only need one road to be good. Okay, you take the best road. Okay, for example, from Perlis, you want to go to Alostar. We have so many route to go there. So maybe you have some, you calculate the sensitivity factor for the option. So maybe using this one, you're gonna take the maximum. Okay, it's the best. Okay, to reach to destination. Although all can reach to destination, but based on this belief, we believe that by using all, we might have not maximum for this antecedent. So in all rule, the overall confidence is strong as the strongest support evidence. Okay, N versus O, mean versus max. Okay, yang ni kita go through ya. I will go through je. Okay, for example, in this one is O, N, and all condition must be whole. So what does it mean? All condition must be satisfied at least partially for the rule to be true. Remember, kalau kita ada N, so all these condition must be true in order to fire that rule. Okay, the rule is true. So that's why I use the minimum take the weakest evidence. In this case, example is 0.6 because this is the lowest. For this analogy, okay, like the water pipe, the smallest pipe limit the flow, and use the mean because the weakest evidence limit the conclusion. Right? Remember, and using mean. Right. But however, if you use or, you're gonna take max. Okay, or take max. Okay, at least one condition is enough for the rule to be true. Okay, using the maximum. Okay, for example, in this case, we're gonna take the maximum. Right. So again, like the multiple road, okay, only one good road is enough to reach the destination. Or use the max because the stronger evidence support the conclusion. Ingat ni je lah. Okay, kalau kalau and, we're going to use the mean. Kalau or, we're going to use the max. Okay, in case of this combination of the CF. Okay, now, again, tadi kita pun dah tengok ada a few example rule. Let's say we have a multiple rules. Okay, sometimes more than one rule can lead to the same conclusion. How do we combine the confidence? Okay, in this case, tadi satu rule. If you notice tadi, before this, I show you one rule but have many antecedent. But here you have a multiple rule. Okay, but this one is only. Okay, guys, saya ulang tadi ya. Kalau tengok yang tadi ni, guys, mana tadi ya? Okay, this one. Okay, kita cuma nak condition ni nak combine nak dapatkan satu final CF untuk one rule. Okay. In this, so that's why kalau kita guna and or just to get the final CF for that particular rule. In this case, okay, kita nak tengok pula on this multiple rule. For example, in this rule number 1, after you got the final rule CF here is 0.7. Okay, and then rule number 2, okay, if humidity is high, then real. So now we have another CF for this rule, 0.6. So hypothesis and conclusion, is it will rain? Right. So now we need both rules support the same conclusion. Right. So how do we combine 0.7 and 0.6 to get the overall confidence? Because now we have more than one rule. Yang tadi itu cuma one rule, cuma ada multiple antecedent. But now you have more than one rule. But how can we combine? Okay. How to get this one? Right. So key takeaway here, a different rule may provide different level of confidence for the same conclusion. So we must combine this confidence to get the final confidence. The stronger combined evidence leads to the stronger belief in the conclusion. Right? So coming up, so we're going to learn how to combine multiple rule positive and negative evidence in the next slide. Okay, now how to calculate here. Okay, rule number 1, yes, 0.7. Okay, rule number 2 got 0.6. Okay. All right, now the same conclusion. Conclusion here is rain. Okay, if you notice here, they have a if sky is dark, then rain. Rule number 2, if humidity is high, then rain. Nampak tak? The answer also rain, but different one. So here, the formula, okay, for example, if you use the positive, okay, so we're gonna put CF, put plus CF1 and plus CF2 multiply by 1 divided by CF1. So we're going to get the combined CF. Alright. Apa tak? Maksudnya macam ni ya. Step by step here. Okay, start with the first CF. So number 1 is 0.7. Okay. And then number 2 is 0.6. So put in this formula. Okay, CF1 plus CF2 multiplied by bracket 1 divided by, so 1 minus by CF1. So here is an example. So put the value 0.7, 0.6, okay, on this one, in this formula. So now you've got 0.88. Nampak tadi you got 0.7, but you got 0.6. But they have a different condition. But now we want to combine, so we got the stronger confidence. Okay, in the conclusion. Okay, by using two rules, we combine, and then we got this 0.88. In this case, because kita dapat certainty factor tu, both are positive. Okay, both are positive. So key takeaway here, multiply positive rule gives a stronger support. Okay, and then we can combine them using the specific formula. Right. So combining positive evidence increase our confidence, but the result we always stay with the range -1 to +1. Of course lah, okay, because this certainty factor we put on this one, kita akan still on this range. So more consistent evidence, stronger confidence, and then last is a better decision lah. At the end, we want to make a decision. Okay, how about combining negative? Okay, combining the negative here. Okay, tadi kalau if you notice guys, before this, if you use a positive, in this formula, we put the divide, right? Sorry, not divide, minus, okay? But this one, the difference is we put, we use apply, we use plus, okay? So rule number one, you got negative 0.4. Rule number two, you got negative 0.7, right? So here is we going to this apply on this formula, right? And then the same process we just put into the formula at the end. Okay, at the end we get negative 0.82. You can see that it's more negative now. It's toward to not trade. So it will not rain tomorrow because of this certainty factor negative 0.82 combination of the negative evidence, right? Key takeaway here, the combined negative confidence now, you got negative 0.82 is stronger than closer to negative 1, right? Then the neither rule is negative 4 and negative 0.7. When we combine, and when we got the strong evidence, so now definitely tomorrow will not rain. So combining negative evidence will give a lower weakest confidence, but never less than 0.1. Of course lah, because it's still dalam range negative 1 and 1. Kalau kita ambil satu je guys, if you just take only one rule to decide, so it's not that much strong evidence, but when we combine them, yes, definitely tomorrow is not going to be rain because due to negative 0.82 certainty factor. Okay. Okay, now I would like to summarize. Okay, if we have this situation, maybe this is not very general, but somehow to give you the key idea, right? Okay, from raw information to the clear and confident decision, number one, you have to have evidence. Okay, we observe the data, facts, and information from the real world. And then from this, information is gathered from the observation, might be from sensor, might be from the survey. Can remember from the survey, you always use the Likert scale, 0 to 5, and etc. Right? So you have some evidence. And then rule, we're going to apply a fuzzy rule in describe how the evidence relate to the outcome. Okay, using the if-else, okay, extract the knowledge into the if-else form. And then single rules, okay, and then the range of the CF, remember, which is negative 1 until positive 1. So what one rule say? Each rule give the confidence, okay, between negative 1 until positive 1. How about the multiple antecedent? Combine them, okay, and then see whether they use the or, whether they use the and. So all conditions in the rule are considered target to get the rule's confidence. How about the multiples condition? So combine them, okay? Let's look on that whether they are positive or they are negative, okay, to the evidence. And then bringing together all rules are combined to reflect the full picture and evidence. And then the final decision, use the final CF and threshold to accept, reject, or to see more evidence. So what we decide, a clear decision is made using the final confidence and threshold. Okay, so this is the complete process from evidence to the rule to the one confident decision. Okay, alright. Any question, guys? Ada soalan tak? Saya baru tengok on this certainty factor. Somehow we're going to see how. Maybe I hope everyone got some input. Okay, so this is how the certainty factor works. Okay, to represent the uncertainty. Okay, right? Can we move to the next method? Is it okay? Ada soalan tak? Saya dah cakap lama ni. Any question? Can we move to the next one? On the fuzzy? Yes, Mr. Hafiz, can we proceed?
Okay, I think we can, we can proceed.
Okay, thank you, Mr. Hafiz. Okay, now I think every one of you might heard about the fuzzy logics. Okay, maybe I just want to share with you. Just now I type, okay, what is a fuzzy logics? Okay, when I type this one, they will come out with this one. Okay, fuzzy logic is an artificial intelligence approach to reasoning with the human decision making. right? And then not true false. Okay, now they also have a degree of truth. Okay, similar to this certainty factor, right? But have you noticed how okay they are good in terms of handling the uncertainty, etc. But have you noticed that there's some of common application that use the fuzzy logic? Siapa tahu application yang guna fuzzy logics? Anyone? Maybe you can type in the chat. Common application that use the fuzzy. Tahu tak apa alat yang pakai fuzzy yang ada dekat ubah kita?
Okay, fuzzy logic ni selalu apa? Digunakan dalam elektronik lah, elektronik sistem.
Anyone? Maybe you can put in the chat if you don't want to talk. Can you give me example? Ada tak example? Siapa tahu fuzzy, ada tak alat elektronik yang pakai fuzzy? Anyone? Saya nak tahu, ada tak yang tahu fuzzy ni ada pakai dekat mana? Chat. Can you give me the answer in the chat? Maybe ni Muhammad Syawal, Aiman. We want to share what washing machine. Yes. Okay, thank you. So Yusrin Rafiq said, oh, washing machine. Right? Okay, what else? Thank you, Yusrin Rafiq. His name quite familiar here. Apa lagi? Contoh. Okay, tadi Yusrin Rafiq said, oh, washing machine use the fuzzy logics. Okay, and then what else? Thank you, Yusrin Rafiq. Okay, vacuum cleaner. Thank you. And Nisrin Fatin said, oh, vacuum cleaner also apply fuzzy. And then Nur Aina said, Nur Aina said a digital video camera. Okay, so there are more. Thank you. Thank you, Yusrin Rafiq. Thank you, Nisrina Fatin and Nur Aina. I just want to get some feedback from you. Okay, I can add also, the rice cooker. Rice cooker also use the fuzzy logics, right? What does it mean? Okay, for example, in this case of washing machine, you put your clothes in the washing machine, right? And then you put the soap there, and then you put some softener, and then you just click start. So what happened behind there? Okay, what happened behind there is the washing machine will estimate how much time will we take to complete to wash your clothes. So it will control. You give the input, and then the fuzzy can control to make sure how much time need to complete. Okay, the same goes to the rice cooker as well. Okay, you put rice, you put water, level the correct one, and then you just click start, right? So they will estimate how long, right? Just just to not to make this just to get some input actually. I think some of you already know, but I just want to ask you, just to get the two ways input. Okay, thank you very much. So okay, let's continue now. Okay, now we're going to continue our topic here under fuzzy logic. Okay, is this person is tall? Okay, so maybe some people might say, oh, the tall should be above 180. Okay, 180 cm, we can call that is tall. But in the certain country, in the certain village might be different. Might be, we might say, 160 is already tall, right? So this is not simply yes or no. Okay, why is it not a simple yes or no? Because in real life, okay, I said to you, tall depend on many things. Okay, on the person age. Okay, because maybe this is a normal. Okay, because this person is in the category of 20 years old. Okay, for example. And then the person's gender, okay, might be some people say, the male and female, the male is taller than female, for example, right? But it's not true for the certain country and region. So the purpose, okay, maybe for the sport, health, job, they have a very specific they want, and then our own standard and experience. Okay, in this case, okay, this guy, okay, the height might have like 200 centimeters. So we may not know the exact height, but we can still say, he is probably tall, or he might not. Okay, for example, if he doesn't get the exact numbers, we might guess, okay, he is probably tall, okay, or it might not, or maybe not. So how fuzzy logic thinks, okay, instead of choosing only tall or not tall, fuzzy logic look at the different degrees. Okay, it consider all the important factors together. It's allowed partial true, negative. Sorry, a person can be somewhat tall. It give a confident level that help us, okay, make a better and more natural decision. Again, as before, a certificate, they are also talking on the confident, okay, because we want to make this is a confident level to on the decision. So the big idea is a fuzzy logic help us make a human-like decision when the answer is not black and white, but matter of a degree. So it's not about being right or wrong. It's being a flexible, realistic, and closer to how we think. Because people might say that fuzzy because they are thinking the decision is they give a no, the answer is not a numbers. They give like a contour. This one tall. It's not. We can describe very tall. It's not that tall. Very small. Very big. Okay, not small. No, they have like the haze. Okay, the haze. Okay, on that decision. Okay, compare between the crisp and the fuzzy. Okay, if you notice in the Boolean operation here, okay, decision are actually between two numbers. Okay, yes, no, again, like before. And then if we represent yes, no in the membership function, maybe we can get this graph, okay, whether 0 or 1. Okay, whether it's yes or no in between, or rigid and not flexible. But if we have these fuzzy logics, so decisions are gradual, many possible degree are chosen. Like for example, oh, 0.2, 0.5, they have like a numbers. Okay, they have a numbers to represent. And then by this number, we also can have this label, okay, or linguistic term. Okay, maybe 0.2 is here, we might say it's a low. Oh, maybe 0.5 is here, or we might say it's a medium, or 0.8, or maybe here is high, and 1.0 or very high. You can see now they have a different way to interpret this result. So many value between 0 to 1 handle the uncertainty, okay, and then flexible and closer to the reality. It's more reality, okay, because again, the real world is not black and white only. They might have different colors. So first, okay, because okay, dalam fuzzy ni ada a few things, few component. So today we're gonna see just a theoretical, and then later on I'm gonna show some example. So first we have to see is a membership function. So membership function show the degree to which a value belong to. Okay, again, let's say, and then we have a value in the membership function, membership value that represent how strongly X belong to a fuzzy set. Remember, if we have a value, remember, if for this we have a value, let's say we have X is 50. X is 50. Now we want to convert this value into the called membership value. If we put here 50 and then we draw, oh, it's a 0.5. So it's 0.6. And also we got this label of linguistic term. In this case, oh, this is a medium. We call membership value for X is medium is 0.6. Right? Okay, this might have a different, but the range here is membership value are between 0 and 1. Okay, 0 is not member, and then 1 is a full member, and 0.5 is partial members. For example, in this case, 50 has two value actually. Okay, the first one is, sorry, one value is a medium, and then the value here, we want to get this value, membership value is here on the X, sorry, on the Y axis. Okay, sorry, this is X axis is called membership value. Y here is a value. Okay, for example, for the input variable, the crisp value, they're going to transform, get the membership value. So unlike the crisp set only 1 and only 0 to 1, but fuzzy set allow the gradual membership between 0 and 1. Right? An example, we can represent temperature, how hot it is, okay, and then how high, how tall is it? Okay, we can say, oh, or speed, how fast is it? Or maybe low, medium, high, very high. No, we will represent on this. Okay, or using this value, fuzzy will apply, and then using the membership, we might get the degree value and also what is the meaning of that. Okay, for example, 0.5, 0.6 is a medium, for example. Okay, here is an example of temperature. we use a word instead of number to describe thing in natural way. Okay, for example here, this one is the real value here, -10 until 60, 50, for example, the temperature. So this number will represent their label here, fuzzy term, a linguistic variable here. Okay, cold, young, hot, and very hot. Okay, so for example, if you got a 50, 50 is very hot. Okay, 30 is hot, and this value. So what is mean? Okay, instead saying 30 degree is hot, true, false. So we might say is somewhat hot. Okay, maybe this one will represent somewhat hot. For example, 0.6. Okay, the value is 0.6. If you go here and then you got this value. So word capture human thinkings more naturally than precise numbers. So meaning that now we got the number and also we have this value from this number. Okay, very cold, young, hot, and etc. Right. So the common linguistic H, sometimes we use the very hot, very warm. Okay, and then somewhat, extremely, slightly, quite, almost. This is called linguistic H. Okay, this H adjusts the meaning and the shape of the fuzzy set. So by using this, people might get this belief as well, right? Degree of truth. So the concept here, the variable, the quantity that we want to describe. For example, temperature. Temperature is a variable. Okay, and then the value is possible state on the condition of variable. Okay, for example, we have 20. The value of temperature is 20. Okay, but what is the membership value? Membership value on this area. Okay, we go here and then we get this value. All right. And then linguistic H is the words or modifier that express the degree or intensity. So very, somewhat, extreme. So this is my, give you, a degree of truth. We might convince the people also on their decision. Okay, and then again, fuzzy set. Tadi kita tengok on linguistic variable. Okay, temperature is a variable, and then linguistic variable is whether it's cold, warm, hot, and very hot. And then they have a number, membership value here. Right. And then it's a fuzzy set. Fuzzy set is element can belong to the set of the degree. Okay. So tadi kita tengok, okay, the first is the universe of discourse is the complete range of possible value. Is the real value on the temperature. Okay, let's say we are talking on the variable temperature. And then we want to see the membership function. Okay, the first one, let's say, on this value, okay, let's say 25 degree, we got 0.6, and then this is 1. Let's say you got 30 degrees, okay, 30 degree is a hot, okay, and then we got the number is 0.7. And then we got very hot here, okay, 40 degree is a very hot, and they got the value of 0.4. Okay, this is all the value. And then this is a fuzzy set. We want to transform here. The fuzzy set is defined by membership function across the universe. So we need to put all of this, okay? For example, cold, young, hot, and very hot. In this case, sometimes you got two value. Okay. For example, here, let's say you see on the 40, you go to the 40, you cross now, you got what? 40, you got hot. Hot is you got the value of hot. Also, you got a value of very hot because you cross two membership here. But okay, yang cold and warm, yes, no, because he's here, right? So when you cross this one, you got two value actually. Okay, for example, look at on the 30. Okay, 30. If you go 30, you got 1, 0.3 because this you cross warm here, 0.3 maybe, and then when we go up here, you got hot. Okay, 0.7. So all of this will be captured is called fuzzy set is defined by this membership function across the universe. So all these values sometimes, okay, if your value is, for example, here, -1, yes, you only have one value, it's a cold, right? For example, here, 0. 0 only have one, okay, 1 for cold. Because it doesn't cross with the other membership or linguistic variable. Yeah. So every temperature belongs to all set, but with a different degree. They have a different degree. So everyone belongs partially. Okay, from cold to hot. All this value we record here. Okay, this is called fuzzy set. So the key idea here is fuzzy set allowed the partial membership, not clear boundary, only gradual transition. Now, okay, just now you remember we are talking about and or, okay, and then complement not. Okay, what happened is and. This is the fuzzy operation. Okay, basic operation on the fuzzy set are performed using membership function. Maybe this is but a bit theory, but I just want to explain. Okay, if you have two here graph like this, but if you keep only one both in the set of the common, we take the mean. So when they have intersection, they just only take the mean. Okay, if we use n intersection, but if we use or mean union, we're gonna use the max. Kalau mean intersection, intersection kita akan ambil yang cross je, right? Yang intersect aja. But if we use max, we gonna got union, we got all of this. Okay, but if we got the complement node, takes everything does not belong to the set. Okay, maybe we're gonna take the other of the set A, for example. So here is an example between A intersect by B. So we got this one. But A union by B, we got all of these. But if the complement not A, of course not A, they will take the different of A. Right. So the result contain only overlap, minimum to set. The result include everything that belong A and B maximum, and then the result is high, where the set is low, and low where the set is high. So this operation work is a membership function between 0 to 1 every point in the universe. This is an operation involved. Okay, and then this is an example of n intersection. So intersection only keep only both fuzzy set have in common. So if we intersect between A and B, maybe on this range, they will get this overlap. Okay, so for example, is value in the X is universe. Okay, for example, A intersect by B. So because everyone have this membership value, remember? So membership A X, membership B X, so they have two value. So intersect, they will only take the minimum. So it's finding the height of the water when two container overlap. Okay, when they are overlap, so the water level cannot be higher than lower. Okay, for example, if X is 50, if X is 50, right? So let's say they got the value of membership A got like 0.6, and then membership B got 0.8. Because of the intersect, we're gonna use the mean, so we're gonna take the mean value. But they have some calculation in fuzzy, but today just a brief idea only. So just want to show you what is involved in this operation, right? We use the intersection and take the mean. But if you use the union, you're going to take the maximum. Similar to the OR. Similar to the OR in the constitutive factor as well. Okay, if you got two value of membership, you want to combine the membership value. Okay, the union, we're going to take the max between both. Okay, for the same example, so the max now is 0.8. Okay, because this is OR operator, right? So the union OR return the maximum membership, okay, accepting anything that belong to A or B. Okay, and then complement is where, okay, and complement is a different of A, right? So I'm not gonna explain more here, but just to give you some basic idea. All right, if you want to find the complement, is meaning that not A, we're gonna get the different other than A. Okay, so this is our operation here, right? So opposite, they said like we can use this formula to calculate is not belong to this one. We use 1 and divide 1 minus by this current value because we want the opposite one. Okay, for example, if 0.3 at the temperature of 35, the membership function is 0.3, but not 1. So we just want 1 minus by 0.3, we got 0.7. And the rest is the same by applying this formula. So complement not flip the membership. Okay, high become low, low become high, the opposite one. Okay, and then here is the other of H, okay, represent in the membership function. For example, guys, in order to represent warm, okay, kalau kita nak represent satu je pun, kita boleh guna apply on the H, okay, linguistic modifier, where is somewhat warm, okay, original warm, okay, very warm, extremely warm, So we can apply this one, no, to make sure that strengthen the degree of truth. Okay, and then they will more meaningful bila ada this H when we apply. So what do the H do is strengthen the meaning, increase the specificity, and then weaken the meaning, increase the generality, then also the add nouns, okay, express the different in the value. Okay, slightly, very, extreme. For example, if you use the very tall, what might we think? Very tall. Very tall is more than tall. Remember? But it's very low. It's more than low. It's very low, right? So by using this, we also can describe our decision. Okay, to strengthen the meaning. All right. Okay, the H of fuzzy set, without changing the universe, they allow us to express the subtle or different in the human language. Okay, here is a example of 25 degrees. Somehow one, maybe 0.3. No, we have a sum of the value represent. H make the fuzzy logic more expressive, just like how we speak naturally. If you notice, why fuzzy apply H's is because you want to make sure there is how people it's a naturally things, right? Very tall, very small, that is we want to apply into this fuzzy linguistic. So here is the fuzzification. They have some of calculation. I will not explain in detail, but normally when we give the crease value to the fuzzy, but at the end we want to convert back from the fuzzy to the crease. Okay, that is the fuzzer in the fuzzy, the last one. Okay, they have some of the area. I'm not explain here because they involve some method and formula, etc. But here the bottom line is defuzzification will transform a fuzzy conclusion into the single action number. So the control system people might have a real world decision. Kan before this we have this linguistic term, linguistic variable, but at the end we also will give the final value to the system, get to the real world to make a decision. Right? So inference system is involve your rule. Okay, the famous one we use the Mamdani. Mamdani is just like this. Okay, example here is if temperature is low and humidity is dry, okay, then the fan is low. Let's say we want to control the field span. So this is the structure of the fuzzy inference by using this Mamdani. Dia ada satu lagi what we call Sugino, but normally we use this lah. Okay, I will teach on using Mamdani because Mamdani is more like a human. Okay, because Sugino they will all use the operation, they will use the function in this consequent rule, right? But here is they have a because they have a the step by step actually in fuzzy. They have fuzzification, fuzzy inference, and then at the end we want to get the final. We apply to defuzzification. So why Mamdani is more dynamic? Because it's more intuitive and easy to understand. Okay, because it mimics like human reasoning if else rule. So handle uncertainty very effective because they have some vague, okay, and then flexible rule base, and then while real world example. So here is the process. Okay, fuzzification plus a rule evaluation plus aggregation plus defuzzification, and then lastly we got some various numbers, creation numbers. Okay, and then using this number we can decide what is the decision as well. Right? So we are towards to the end actually. Okay. All right. The AI application we can apply in many more. Okay. Let's say in the healthcare, automotive vehicle, where the forecasting, financials, okay, smart home, thermal confirm. Okay, because at the moment we are working together with Mr. Hafiz, we are doing on the thermal comfort prediction. Okay, and when let's say we have an input here, and then we will apply into the fuzzy system, and then they will give the final result. Okay, let's say the defuzzification will return 0.7574. So 74, and then we will try and then test. Oh, there is the comfortable, for example. And then we give also the confident, okay, 9.2.3, right? And then there is like a dashboard prototype, for example, here. So meaning that based on this input, they can control. We can get, if this one, what we're gonna do? Okay, maybe we want to increase, okay, not increase the aircon and etc. Okay, in the thermal comfort prediction in the particular room. So fuzzy logic allow AI system to reason with the uncertain and precise information that making prediction closer to the human comfort in real world reality. But any question? We are almost to the end. Okay, if you don't have any question, I just want to show you the example. Okay, this is just to recap. So understanding the uncertainty, okay, and then certainty factor, single rule, multiply rules. Okay, but in fuzzy logics, okay, we handle uncertainty using the membership function and then using the fuzzy operation. And then we also learn about some example on the AI application. So again, AI is not only about the making decision, it is about making the reliable decision even when the information is uncertain. Okay, just want to show some example. I'm working this one, I think with Mr. Hafiz, right? Cik Hafiz. So for example, in real world, in the Mango, no, sometimes we want to make a grading. So we apply some of the if-else rules, okay, and then do the coding here, okay, to explain, to make a decision. For example here, I would like to show you some example here. Okay, let's say we have a 1, 2, 3 category of mangoes. Okay, for example, we try to grade based on the medium and the color and then the skin. For this case, number one, okay, based on the medium, the size medium, the color is good, and then the skin is excellent. Oh, maybe this one is grade is A. Go to the number 3. Okay, if the size large, okay, the color is poor, the skin is poor, oh, maybe this one is a grade C. But somehow, for number 2, sometimes we doesn't certain, okay, whether they are A or whether they are B or whether they are C. No? So there is no single correct answer. Different people might give a different rating. So there is where fuzzy logic. Yeah. Okay. For example, we go ask people. This is just to summarize. Yeah. I will not explain. So let's say we ask people, okay, to rate the same mango. So if you can notice here, they have some difference in answer, even though we do have the grading far more, for example, but also we got the different. Maybe because of why? Because it's the uncertainty or because of the preference of the humans. Okay, because of the subjective and the personal bias. Okay, so they might have a different answer. So we collect all this expert knowledge, okay, and then we put all together, okay, into this example, and then we transform into the data set structure, and then go to the M1, okay, by using expert ABC. So we will do the combine. So converting the expert system knowledge into fuzzy rule, it can handle the uncertainty, and then it can reduce the inconsistency by the grading system is consistent, accurate, and interpretable. Right. So here is the step lah we did, and then until we got the data, and then we do the combine, and then we aggregate the data, and then from there we can based on 3 input only: size, color, and skin. Okay, and then we can combine into this fuzzy lah. At the end, we want to do a grading whether it's A, B, or C. Okay, and then there is some sample of the detailed system, and then there's some membership function. Okay, I will not explain detail, but just give you example how we can apply. Right. So and then organizing the knowledge circle. Okay, and then we want to evaluate the fuzzy system. And then, for example, we put the size is this one, and then color is this one, and then the skin is with this number, and then we can do the prediction. And then the final grade is B. This is a new data that we try to use this, we call slide. Okay, because let's say we already have a fuzzy system, and then we use this slide, and then they will process the data until at the end we got based on this input, the final grade is B. What does B mean? B means a good quality, right? So here is can do the interpretation, and also we can do some performance. I think this why it's okay. Just to compare between fuzzy and hierarchical, and then compare back to the human. And then interpretable, as I mentioned before this, people now go to the XAI, we want also not only accuracy, we want also the explainable. The system also can explainable, can justify the result. Okay, to that, I think, thank you very much. I think that's the end of the session, sharing session. So maybe you guys have some question or, ada soalan tak? Okay, this is my detail, my email, my numbers. Okay, if you have idea, if you have collaboration or we have innovation forward, okay, feel free to contact me, and then maybe we can do focus. do collaborate. Right, I think to that, that is the end of my lecture. Thank you very much. I give back to Mr. Hafiz.
Okay. Hello. First and foremost, I would like to express our gratitude to Dr. Tajul Rosli because he is able to spend his valuable time in tonight's sharing session. So tonight's session is for covering our fuzzy logic and uncertainty in reasoning in uncertain situation topic, whereas it is a final chapter in our class. So for other information, Dr. Tajul is also a lecturer in Faculty of Computer Science in Shah, and he is head in Computer Science Department lah, kalau tak salah kan, head
Yeah, coordinator
coordinator.
coordinator CS 230.
CS230, which is nanti apa nak sentrik pun dia akan folded bawah CS230 lah,
Yes.
within the next year. So you all nanti merupakan batch yang terakhir ni, CS2251 ni.
Oh, ini
Antara
CS 251 Hafiz.
Nah,
Oh, nanti tak
antara
ada.
batch yang terakhir lah. By next year dah tak ada lah. So dia
Dia akan masuk ke dalam 230.
And then kalau kata any of you yang ada berminat untuk sambung study dalam bahagian research master, mungkin boleh contact juga Dr. Tajul lah. Dr. Tajul ada banyak ni lah, banyak projek lah for master. Okay, master ataupun postgraduate within net-centric dengan computer science. Okay, Bachelor of Computer Science kalau nak sambung pada master degree.
Kalau tak silap saya di degree di master dekat Shah Alam, kita ada master computer science, kita ada master data science, ada master cyber security, dia ada few yang coursework. That one is a coursework lah. And then kita ada juga master by research lah in computer science and IT.
Oh, yang data science dia tak ada ni lah, dia tak ada by research lah.
No, data science, okay, yang coursework dia ada master data science, cyber security, and also ada satu computer science tapi yang coursework. Tapi kita ada lagi dua yang by research. By research cuma ada IT
dengan
and CS.
Okay. So yang tu lah. Okay, kita learn a new information today. So for the rest of you, hari Isnin ni kita tetap akan ada kelas. Cuma hari Rabu next week tu kita dah tak ada dah kelas lah for our Monday session. Saya akan buat final year examination discussion. So kita akan go through one by one. So kalau ikutkan by the end of this tonight session, kamu sepatutnya boleh jawab semua dah soalan final examination macam kita discuss last week. So today pun dia punya topik pun hanya untuk sub soalan lah. Dia bukan macam soalan yang structure yang besar tu. Sub soalan. So I encourage you to do the exercise, and then kalau ada masalah nanti jumpa saya, sebab tak semua orang yang pemahaman dia sama, terutama macam nak lukis graf ataupun nak buat rule based punya uncertainty. Ada setengah orang pemahaman dia lain, terutama satu lagi minimax. Ada setengah student bila dia tengok video saya dia terus dapat, ada yang tak dapat lagi lah. So nanti depend lah, nanti jumpa saya dekat office lah by next week. Last kali kita akan buat tutorial by Isnin ni lah. Isnin ni. So for the rest of you also, do not forget to fill in your attendance. Okay, attendance hari ni akan diguna pakai. And then good luck to all of you. Alright, okay, thank you for tonight.
Thank you semua. Terima kasih.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, Dr. Tajul.
Thank you, sir.
Assalamualaikum.
Okay, Waalaikumsalam. Thank you Dr. Tajul.
Bye.